Show you something. This is a MOSFET. It is a fast switching transistor, and on power supplies it is connected after the DC capacitor and before the primary windings of a transformer. So this is the DC capacitor, the MOSFET, and this is the transformer, and usually they are on a heat sink. This is the capacitor, this is the MOSFET, and this is the transformer. So the MOSFET, we have the 3 pins, the base, the collector, and the emitter. So think of the MOSFET like a switch that is opened and closed electronically. So when you come with a small current on the base, a large current can flow between the collector and the emitter. So the collector is connected on the large voltage supply, and the emitter is the output of that supply. So the small current on the base to close the switch between the collector and the emitter is in form of a PWM signal, pulse with modulation, and it is generated by a PWM controller. So when you talk about the PWM signal, you can think of a square wave with a high and a low. So the high is the amplitude, that could be 10 or 5 volts, that the peak, and the low is 0, so the low is off and the high is on, and before a waveform repeats itself. This is called a cycle. So this is one cycle and this is another cycle. When the PWM signal is high, this switch is closed, and when it is low, the switch is open. So in a cycle, we are talking about on time and off time. So in this one cycle, the signal is on half of the time. That is the on time, and that is called the duty cycle. So the duty cycle of this waveform is 50%. On another scenario, the signal could be on a quarter of the time in one cycle. So with this, we talk about 25% duty cycle. The PWM controller is generating these high frequency signals in the kilohertz. That is, you can have more than 1000 cycles in 1 second. So the input of a power supply is 240 volts AC. So this voltage is rectified by the bridge rectifier, and at this capacitor you will have the peak voltage, which is 340 volts DC. So you can get this 340 by multiplying the AC voltage by square root of 2 to get the peak DC voltage. This MOSFET is constantly switching the 340 volts DC to ground through this transformer. I'm sure you understand how transformers work. When you pass a high current through a coil, you generate a high magnetic field, and that's how you increase the voltage at the output. So the PWM controller is always adjusting the duty cycle to ensure that the output voltage is always maintained.